So again, thank you everyone for joining today, this webinar that will be held by Dr. Roberto Rocca regarding presenting the use case of a CLARUS Horizon project as an example of usage of AI and digital-based technologies and data space to improve environmental sustainability in the process industry, and we will discuss also its applications for cosmetics industry. So before starting with the webinar itself, I would like to share a moment the screen just to give you a little bit of context regarding this webinar series that we are having here. So everything is, this webinar series is occurring in the context of the Act for Cosmetics project. Act for Cosmetics is an Horizon Europe project from the European Innovation Ecosystem Program, which is revolving around three main pillars related to innovation throughout the European cosmetic value chain for what concerns digital transition, innovation for what concerns green transition, and raising awareness among customers, citizens, and every other stakeholder about the importance and the meaningfulness for the European system of the cosmetics sector, which, as many of us know, is often a bit overlooked. So in this context, we have that the project started in May 2023. It will end in April 2028. It's coordinated by Cosmetic Valley and counts 8 different full partners and 2 associate partners coming from a total of 6 different European countries. It's being developed in the framework of the platform known as Go for Cosmetics, which is connecting all the relevant European cosmetic clusters. So how does this project work? We basically are working in identifying the major needs and trends inside the European cosmetics industry. Then, starting from that, we are developing through working groups ideas for innovation with contribution also from experts from outside the consortium. And then we are defining concept notes related to these innovation ideas that can stimulate competitiveness of the European cosmetics industry. In this context, we are carrying out several training activities, including this series of webinars, which takes place in the context of the Observatory belonging to Act for Cosmetics project. So what is the aim of webinars like the one that Roberto is going to deliver? We want to share with all potentially interested stakeholders of the cosmetics industry the best practices and latest results emerging from research innovation projects and works that can be directly related to the cosmetics industry or can be related to other close sectors, but have potential to be transferred in the cosmetics industry in terms of ideas, in terms of results, in terms of concepts. Just before deep diving in the rules for today's webinar, with the aim of mapping the trends and the needs of the cosmetics industry, we are performing a series of surveys that need collaboration of as many interviews as possible. So we are currently working on these 3 surveys that you can see here. One about training and solutions to stimulate young talents for the cosmetics industry, one related to water management, and one related to reuse and recycling of cosmetics packaging. Here you can see the links and the QR codes to access the surveys if you want to contribute to these actions. you can scan the QR code, or once the slides will be available for you, you can click on the links. Finally, please keep mic muted and camera turned off during the presentation. There will be the Q&A session after the presentation itself. During the presentation, you can type all your questions in the Q&A chat, all your questions in your Q&A chat, and we will answer to them collectively after the presentation in the Q&A section. Slides and recording of the presentation will be shared with you, with and also the people who subscribed but couldn't attend. So, thank you for listening to this initial introduction. Now I'll leave the floor to Roberto, please.
Thank you very much, Daniele. Good afternoon to everyone. I'm going to share my screen, so please confirm that you are able to see my slide.
Yes, we can.
Okay, thank you very much, Daniele. Well, good afternoon again to everyone. My name is Roberto Rocca, and I come from Politecnico di Milano, and I'm going to deliver this webinar that will last more or less 1 hour about potentialities of artificial intelligence for sustainable manufacturing in process industry, from food to cosmetics, the case of CLARUS project. So the aim of this webinar is to introduce some pillars and some characteristics that are transforming cosmetics value chain under a sustainability perspectives, and highlight some similarities between cosmetics industries and food industries under a optimization production processes point of view. In particular, I will deep dive a couple of digital technologies offering the Industry 4.0 paradigm that are artificial intelligence and industrial architectures in general and in specific data spaces, and how these technologies can be utilized to improve environmental sustainability performances in the process industries. In particular, I will tell some insights and results that comes from the CLARUS project, that is a European project that deal with these technologies applied to food sectors to improve environmental sustainability performances, and also discussing some similarities of the CLARUS approach and potentialities of these technologies to cosmetics industries. A couple of words to introduce myself. As I said, I'm from Politecnico di Milano. I'm a management engineer. I obtained my degrees and the PhD in Politecnico di Milano, and I deal with sustainability topics. So I work in Politecnico dealing with didactic consultancies and research activities related to sustainability, sustainable manufacturing, and in particular to all the research area related to metrics, methodologies, and tools to evaluate and optimize sustainability performances in process industries. And of course, within process industries, I deal with several sectors, like as in fact the food sectors and the cosmetic sectors. And another important part of my activities is related to deepen the technological and technical maturity of manufacturing companies to apply certain type of digital technologies to improve environmental sustainability performances. This is the brief agenda of this webinar. I will just introduce some main important characteristics that are affecting cosmetics industries nowadays under a sustainability point of view, and then I will introduce CLARUS project, showing some possible application of artificial intelligence to improve environmental sustainability performances, and then we will have some minutes available to discuss and any doubts, curiosity, or question about the topic of the webinar. So the preliminary consideration is, of course, related to the sustainability issues that our societies, and in particular manufacturing sector, is facing nowadays. Of course, manufacturing sectors is one of the main contributors of our societies that have to deal with climate change, sustainability issues, especially because of the exploitation and utilization of certain type of huge amount of natural resources that manufacturing companies utilize to produce and to deliver our products and our services. And as we know, the majority of the manufacturing sector of our societies are dealing with these challenges, with these sustainability challenges, because of different type of reason related to the restrictions in terms of availability of resources, but also different changing in terms of behavior of purchasing of the final customer, and also the requirements of the supply chain. All this pressure that is present in manufacturing strategies at the end turns for manufacturing companies to the need to integrate sustainability within the strategies of the company in order to achieve a competitive advantage within the sectors. This because we have to have in mind always that there is a bidirectional relationship between our activities in terms of manufacturing sectors and the environment, that at the end is the stakeholders of our societies that provide to manufacturing sector all the environmental resources necessary to build and produce our product and our processes. And among the different sectors that are dealing with this importance to integrate environment as stakeholders of the company, we find, of course, also cosmetics industries, food industries, and in general the process industries that are among the main contributors in terms of consumption of different natural resources like energies, waters, and materials. What does it mean for the companies, for manufacturing companies, to integrate the environment as stakeholders of their strategies? Well, it means to find the correct actions, strategies, and investment for these companies to improve the environmental performances of operations, processes, and product within the different business units of the companies. And if I would summarize the main area in which manufacturing companies are investing to achieve better environmental sustainability performances, we can summarize this investment in the 7 bullet points that you find in this slide, that range from the adoption of digital technologies and the build of industrial architecture and data space to improve sustainability performances, but also energy efficiency investment, circular economy action, and of course measurement of the performances of the supply chain, so the green supply chain and environmental measurement of suppliers, but also sustainability measurement at process level in order to decarbonize production processes and final product. This term, decarbonization, is one of the main important terms that we heard continuously when we speak about sustainability and climate change issues in manufacturing sectors. And is at the end one of the main important terms that summarize the need to achieve a lower level of environmental load in terms of product and processes. And of course, these main objectives of European Commission and of European societies to decarbonize manufacturing sector involve also a lot of effort and actions in cosmetics. This because cosmetics, as we know, as part of the chemical sectors, consume a huge amount of natural resources from the raw materials for the formulation of cosmetics product to the packaging production until to the consumption of water, energies, and many other materials and chemicals. So being part of this type of sectors that consume a lot of natural resources, the pressure on cosmetics companies and in general on cosmetics industries to put some effort to decarbonize the entire supply chain is increasing a lot during the last period. And of course, one of the main important actions that cosmetic companies is put in place nowadays to lowering the environmental load of product and processes is the measurement of the current production in order to detect the main important critical areas on which the companies can invest to reducing environmental impact. So at the end, among all the areas that I show in the previous slide, the measurement of the sustainability performances is one of the key action, one of the first of the main important actions that cosmetic company should put in place in order to analyze the entire supply chain of the cosmetics product as well as the entire life cycle. Because just measuring, of course, with the right instrument, tools, and metrics, the current environmental load of cosmetics product, we are able to improve it. So to detect the most important critical areas and the main important actions that we can put in place to improve environmental sustainability performances of our cosmetics product in order to decarbonize the industries. And of course, we know that cosmetics industries is characterized by a very heterogeneous dynamics of stakeholders involved in the supply chain, because we know that several actors plays a key role in the production of cosmetics product, from the raw materials extraction, selection, and formula development till to the manufacturing phase, the production phase, as well as to the part of the supply chain that is related to the packaging. So the design of the packaging, the manufacturing of the packaging, and of course, the filling phase and the distribution phase. So these heterogeneous dynamics of cosmetics supply chains involve the effort of all the actors to achieve better sustainability performances of production processes and products. And of course, this complexity, we can say, or at least heterogeneity of actors involved in cosmetics industries at the end turn in different phases that characterize the life cycle of cosmetics products. So ranging from the design phase of the formulation as well as of the packaging till to the post-consumer use, there are several possible areas in which cosmetic companies can improve the load in terms of environmental impact of the product. And if we want to summarize, or at least to clustering, the main important area in which cosmetics companies can improve their performances in terms of environmental sustainability, we can state that sustainable procurement from one side, resource efficiency from the other side, and packaging as a third area are the three main important areas to improve environmental performances. The sustainable procurement, of course, is related to twofold objectives. That is, from one side, to find always more sustainable raw materials for the formulation of the cosmetics product, and in parallel to select the more sustainable suppliers that are able to provide with higher sustainability level of performances the raw materials to our company. And of course, this is one of the main important part in terms of research and investment for cosmetics company to find new solution with, for example, lower emission of carbon dioxide, as well as a lower ecotoxicity, as well as a reduce in general the overall environmental impact. The second main area is the improvement of the efficiency in terms of use of resources. So, for example, energy efficiency, water efficiency, or material efficiency. So, produce the same amount of products that we need, but utilize in a better way our resources. And of course, this means efficiency from one side, but also effectiveness from the other side. So, for example, leveraging on circular economy paradigm and circular economy key principles, for example, recyclability, reutilization, and reusage of resources and product. And at the end, the packaging side. The packaging side that, as we know very well, is an active packaging for cosmetics product because can react also with the content of our product. So finding new, more sustainable solution for packaging in cosmetic supply chains mean to also to be careful to the main important aspect of the packaging, that is from one side to contain the product, but also from the other side to react at chemical level in the right way with the content of our product. So, of course, there are many other actions and possibilities to improve the environmental load in cosmetics, but we can, as I said, we can clustering this main action in these three areas. And take care that if I would come back in my previous slides until now, and if I would change the terms cosmetics with the terms food, most of the content that I have discussed until now are the same. This because the food sectors, as well as the food supply chain, is very similar to the cosmetic sector under a sustainability point of view and under a process management point of view. So we can easily start to understand that there are a lot of similarities in terms of sustainability management under an environmental point of view and under a natural resources management of natural resources point of view. So also the next solution that I will present that comes from the CLARUS project that is related to the food sector are totally fine also to be applied in cosmetic sector. So coming back to our potential improvement within the cosmetic supply chain and cosmetic product life cycle, of course, we have said there are different area in which we can apply potential improvement. The right question is, where are the main benefits that we can achieve in redesigning a cosmetic product? Of course, the answer can be different according to different type of product, different type of production, but also different type of configuration of the supply chain. So the right answer has to start always from a measurement point of view. So the right way to define what are the most important benefits that we can achieve in a cosmetic product life cycle is to measure. Just measuring the as-is situation of our product, of our cosmetics product, we are able to detect the main important critical area under a sustainability point of view and decide which are the main important action that we can put in place. So measuring means measuring this environmental perspective of product and processes means to, of course, knowing the best tools to utilize to measure these environmental performances, but also um, to know and understand which are the best data that we have to gather, collect, and analyze to measure these environmental sustainability performances. So we can summarize all this information with the terms environmental sustainability data. So every time that we want to analyze the current status of environmental performances of our product in cosmetics, we should be able to analyze the correct environmental sustainability data that are at the end the source of information that are strictly related to environmental sustainability. So just if we are able to collect, analyze, and trace in the right way these environmental sustainability data, so we are able to measure in the right way the level of sustainability of our production process and product. And of course, nowadays, there are many digital technologies that can help us to detect which are the main important data to collect and which are the best model to analyze this data. So, one of the main efforts that the companies are putting in place is to design new industrial flexible architectures with adequate communication protocols and digital technologies to gather this environmental sustainability data and elaborate this environmental sustainability data to achieve better performances in terms of sustainability. So, under this vision of integration of digital technologies to support environmental sustainability perspectives of cosmetics product and processes, we can state that we are in a new concept of smart and sustainable cosmetics manufacturing. So there are many terms nowadays that are utilized in industrial environment like smart and sustainable manufacturing, as well as twin transition, as well as Industry 5.0, and so on. But in general, we can summarize that all these terms put a very high attention on how the two main challenges that manufacturing companies are living nowadays, that are digitalization and sustainability converge in a useful point to exploit digital technologies to support environmental sustainability performances. So under this perspective, we can see this twin transition and this smart and sustainable cosmetics manufacturing as a new paradigm where the application of digital technologies can be seen as an evolution of the sustainable manufacturing. So nowadays there are different action points in which we are able to integrate digital technologies to support sustainability transition. And of course, the technologies that we can consider to achieve these performances are many, that range from the industrial Internet of Things and the application of intelligent sensor, development of cyber physical system, as well as digital twin, but also application of mathematical model and in general industrial analytics to find new pattern within huge amount of data set that characterized our environmental sustainability data. And of course, one of the main challenge for companies that would like to integrate these digital technologies to achieve better sustainability performances is also to find the correct technical way to let different protocols to speak each others. Because actually what we find in our manufacturing systems in general is that there are, of course, present old system or in general legacy systems that are not a greenfield solution in terms of digitalization, but that we would like to let to speak each other with these new digital technologies. So one of these main challenge for manufacturing companies and of course for cosmetics manufacturing companies is to find the right technologies and the right way to implement, to install within the legacy vertical solution. I have introduced before that among these paradigm of Industry 4.0 technologies and digitalization in general, I would put the attention on two main technologies that we are deepening in CLARUS project and that is possible to be exploited for the improvement of sustainability performances. These two technologies are artificial intelligence from one side and data space from the other side. Of course, artificial intelligence is a term that we continuously heard every day, also in our daily life for many different reasons, but is also one of the main important technologies that is going to be more than ever introduced at field level, so at process level in manufacturing companies to treat some useful information and data that comes from machines, equipment, and so on. And we can state that artificial intelligence, as well as neural network, machine learning, and many other terms like this are all part of the industrial analytics technologies. The second technologies that I have mentioned is the data space. What is the data space? Well, the name is quite easy to understand, is a virtual space of data that the company can utilize to improve the flexibility through which they manage the information within their factories and in general within their business units. Why data space are obtaining an increased importance in this digital transformation of our manufacturing companies? Well, the first consideration is that the majority of industrial information and data that are generated from the processes in manufacturing sector are not utilized. So if we think about all the information that are related to the production, to the factories, to the supply chain, and to the characteristics of the different phases of the product life cycle, in most of the cases, the majorities of these data are not utilized. And the reasons are many. There are worry always or sometimes for the company about uncovering valuable data and trade secrets. So there are often some reasons that are related to the competition on the market that doesn't allow to the company to share and utilize this data. But also the fear of losing control on this data, and in sometimes also the fear that the platforms that exist to manage this data are not sure. So cybersecurity issues and also the fear of losing the capability to take an advantage of manage this data. And the advancement in terms of digital solution applied by manufacturing companies nowadays can overcome this concern thanks to some type of solutions that industrial architectures like a data space can provide, that are trust and security to share the data among the different stakeholders of the supply chain, to provide a data sovereignty, as well as to provide an interoperability, so a capability to let different type of system to share different model and format of data, and also to achieve critical mass to obtain concrete benefits in terms of sharing of this data. All these solutions can be integrated in the concept of data space. That, as I said, is a virtual space of data in which different companies and stakeholders can share their data. So the basic concept of data space relies to the concept that we need some entities that provide the data and some entities that consume the data. And in order to build these platforms or architectures, or in general, virtual space in which the companies are able to share the data, we need some technical building blocks that allow us to obtain this solution. Now, I don't want to go too much in technical details in this webinar because it's not the scope of this webinar, but I would like just to highlight which are the main group of technology building blocks that we need if we want to build a data space. Of course, some building blocks, so some technical components that allow us data interoperability, so the capability of different communication protocols, different formats of data, and different models of data to exchange information among different entities. The capability to provide data sovereignty and trust, so to decreasing the fear of the company in terms of trust of sharing the data. The data value creation, so the capability to generate marketplace of services, information, and useful application, and of course, a series of applications that allow the entities of the data space to generate a governance of the data space, so business agreements, operational agreements, and organizational agreements. The concept of data space is finding a lot of importance in industrial sectors nowadays, especially also in research areas. So there are a lot of European projects that are dealing with this concept in order to build flexible and structured data space in manufacturing sector, and the CLARUS project that I'm going to show you in the next slide rely a lot on this concept. So in general, the guideline that is possible to follow to build a data space are the guidelines from the International Data Space Association that provide all the characteristics to build this type of data space, where that data providers and data consumers are present, as well as the technical aspect and technological building blocks like a connector, broker, identity provider, and many other services are present to create this space in which the data is possible to be exchanged in a sure way. And of course, is what we are going to build also in CLARUS project. So, after this introduction on the main characteristics that are characterizing cosmetics industries, I would like now to go deeper in the main important aspect of the CLARUS project, because the CLARUS project is an European research project in which we are deepening the application of technical characteristics that I have introduced in the previous slides in order to optimize the production and logistic resources in the time-critical bioproduction industry in Europe, with a specific focus on food industries. The project has started in September 2022 and is going to finish in few months at the end of August of this year. Politecnico di Milano is the coordinator of the project, where many other partners are present. So here you can find all the partners that compose the consortium of the CLARUS project. There are 3 universities that are Politecnico di Milano, Tampere University, and Universitat Politecnica de Valencia. Then we have one large enterprise that is the IT provider of the technical component to build the data space within the project. 2 research centers, Ikerland from Spain and No Center from Austria. Then we have one small medium enterprise that is Expert AI that deal with the technical and legal aspect of artificial intelligence, and 2 industrial pilot, that is Onkajoki, that is a Finnish company together with its associate GMM, and the second industrial pilot from Spain, that is Ardo. So now I will going to explain the main characteristics and the results of CLARUS project, highlighting the application of artificial intelligence and data space to improve sustainability performances of food production process, and of course putting the light on the characteristics that are totally similar to the cosmetics industry. So I will explain some AI tasks as well as indicators, as well as process characteristics that, of course, are related to the specific of the pilots that are involved in CLARUS, but we can easily generalize for many other food companies as well as many other process companies. That it means also cosmetics companies. So the context of the project, as I said, is the food industries, and in particular to create a convergence between the green transition to achieve better sustainability performances in food production change enabled by digital transformation, in specific with artificial intelligence and data space application. So the main objectives of the project that is part of the digital emerging section of Horizon Europe project, that are the part related to AI, data, and robotics. The main objectives is to create a novel platform with high communication and processing capabilities that is able to support the improvement of sustainability performances for food companies. So here we find the main key important topic that we have introduced in the first slide, that are the sustainability data. So in this case, the environmental sustainability data are the core information analyzed within the project to achieve better performances of the industries involved in the project. The 2 industrial pilots that are involved in the project, as I said, are Onkajoki, that is a Finnish company that produce pet food from the slaughterhouses in Finland, and the second company is Ardo, that is a Spanish company that produce frozen vegetables, and also and for this reason has a very high attention on the consumption of waters, energies, and many other natural resources. So are both 2 examples of food companies that take care a lot on sustainability topics, and that would like to improve the sustainability performances integrating digital technologies. So if we consider the entire supply chain of the food sector, the main attention of the CLARUS project on these two pilot is related to the process industry. So the way through which the pet food is produced, and of course for the second pilot, the way through which these frozen vegetables are delivered and produced. A second important aspect outside the processing of the production is related to the logistics. So the second main area of improvement that we are trying to achieve in CLARUS is related to logistics parameter, in particular to the first pilot that is on Kyoki, where the logistics phase to collect all the waste from the slaughterhouses to produce the pet food take care a lot to logistics parameter. The main ambition of the project, according to the scope that I have described before, is to find the correct way to analyze the impact of artificial intelligence and data space on the main important environmental sustainability program delivered by European Commission. That is the Green Deal. So the Green Deal parameters are at the core importance for the project because provide the metrics to analyze the impact of artificial intelligence and data space, and in particular measure the improvement of environmental sustainability performances. So according to this ambition, the main scope of the project is to deliver 3 tangible expected outcomes that represent the concrete results of the project, that are in fact the CLARUS Green Deal Index, that is an overall indicators able to measure the improvement of the companies involved under a Green Deal perspective. So is an overall indicator that measures the main important parameters of sustainability in food production processes. The second tangible expected outcomes is the CLARUS data space, so the building of a data space to allow to the company to share environmental sustainability data in a trustful way. And third, the third tangible expected outcomes is the CLARUS AI toolkit. So a set of selected artificial intelligence algorithms that can be applied thanks to the data space to improve the level of the Green Deal Index. In fact, if we want to summarize the approach of the project, there is a totally connected vision of these 3 tangible expected outcomes to build the overall platforms of the CLARUS project. In fact, the 2 industrial pilots on Kyoki company and Ardo company provide all the useful information, data, and metrics to feed the CLARUS data space, as well as to testing and train the AI algorithm that are part of the AI toolkit. With this algorithm, then the environmental sustainability performances are measured by the CLARUS Green Deal Index, that is the overall indicator, as I said, to measure the environmental sustainability performances of the food process analyzed, that at the end concretize itself with the possible solution and benefits to the CLARUS pilot. So the overall platform that is based on these 3 pillars that are Green Deal Index, AI Toolkit, and Data Space allow to provide a unique solution, so a comprehensive tool that is able to assess sustainability variables, so sustainability data within production processes like water, energy, waste, logistics, to optimize industrial processes from food production to logistics, and of course, to create a digital platform for decision making for the companies involved. And of course, being built on data space and artificial intelligence concept, the CLARUS solution involve the different level of the industrial architecture of the companies that range from the field level, so from production process, equipment, tools and machines, as well as edge computing, manufacturing execution system, until the cloud system of the company. So the CLARUS solution has the major objective to cover all the level of the IT architectures. So according to the characteristics of the data space that I have described before, and according to the ambition, objectives, and approach of CLARUS solution, this is a tentative structures of the data space that we are going to build within the project. So we have the two industrial pilots, so Ardo and Onkayoki company, that are the data owners, so the owners of the environmental sustainability information that comes from the production processes. Then we have engineering, that is the large enterprise that provide the true connector, that is the technical building blocks to build the data space. And then we have the other stakeholders of the data space, that are the research centers and the universities of the CLARUS project, that provide artificial intelligence algorithm, metrics to analyze the Green Deal Index, and tools to evaluate sustainability performances. So at the end, the data start from the data owners, pass through the different stakeholders of the data space, technical and non-technical stakeholders, for coming back to the data owners that became data consumers in order to apply the potential benefits achieved thanks to the artificial intelligence application. So I would leave the last part of the webinar trying to tell you some insight and results that we have obtained until now on one of the two industrial pilots involved in the project. Of course, I don't have time now to go deep in the technical aspect of the connectors of the data space and of the mathematical models, but I would like to give you an overview of the approach of CLARUS project within these real companies, and which are the main parameters analyzed and the main results that we are going to achieve. This company, as I said, is Ardo, that is one of the two industrial pilots involved in the project, and is a Spanish company that produce frozen vegetables like peppers, broccoli, carrots, potatoes, and many other vegetables. So just to give you a very high-level overview of the factories to highlight the main production process phases that we are analyzing in the project. We have a production phases with all the equipment, machines and tools that produce the vegetables. We have a second main important area, that is the freezing tunnel, so the cold store area of the company that aims to frozen the vegetables. And then, of course, we have the last part of the factories where the different vegetables are frozen, packed, and then delivered outside the factory. So, which are the main objectives for these companies? This is an overall schema of the main use case that we are analyzing within the project. In particular, we have in the Ardo pilot one use case that is related to the energy consumption optimization, and one use case that is related to the water consumption optimization. So the AI models that we are testing within these two use cases are related to the electric failures, to the freezing installation anomaly detection, and to the freezing installation setup optimization for the energy consumption use case, and to the water consumption anomaly detection, and to the water pump predictive maintenance, to the water distribution. So a series of artificial intelligence algorithms that have the overall objective to improve the anomalies, the failures, and the problems that are present in the current state of the processes. Which are the main benefits and the main objectives of these artificial intelligence algorithms are those that you find in the purple box. So, for example, the prediction of failures, the detection of anomalies, the optimization of the freezing installation, as well as the detection of frost in freezing tunnel and predictive maintenance of water pumps in the water distribution use case. So the main approach from an AI point of view has been to select the best models for this problem and then train a set of dataset that comes from the production process of the companies. Of course, the application of these artificial intelligence algorithm can allow to the company to analyze in a better way the data, so the environmental sustainability data, in order to achieve certain type of benefits like the increase of the equipment availability, the increase of the energy efficiency, as well as the increase of water availability. Moreover, we are analyzing also another artificial intelligence objectives, that is the prediction of the energy budget. So the energy data are also analyzed to optimize the energy distribution within the production process according to the contract that are present with the energy suppliers. This is a very high-level schema of the production process. We have a different type of phase. In particular, there is the preparation phase where the vegetables are cleaned and washed. Then we have the blanching phase and the freezing phase. So the blanching phase and the freezing phase are the part of the production process that are characterized by the high level of energy consumption and are, for this reason, the part of the production process on which the artificial intelligence algorithms are applied to optimize the production process. Of course, there are different type of equipment involved in the production process, like compressors, condensers, pumps, evaporators, and many others that are, of course, all equipment that are characterized by high level of energy consumption and water consumption. So, summarizing the main environmental sustainability data that we are going to analyze in the project are the data that comes from the electricity consumption because of the processing machinery and because of the refrigeration tunnel of the company, to the gas consumption for the blanching phase and from the heating cleaning water, and thirdly from the water consumption in the different phase that we have analyzed before. All the equipments of this process that I have described are equipped by different type of sensors that have the objective to gather all the environmental sustainability data. So data related to the water consumption, data related to the energy consumption, as well as other environmental variables like temperatures, pressures, and, for example, ammonia consumption, that is the fluid utilized in the freezing section. All these sensors, water, electricity, ammonia, temperature, pressures, and so on, have the overall objective to analyze the energy efficiency of the systems that is described by the COP indicators. So the COP, or coefficient of performance, is a common indicator that measures the energy efficiency of a freezing installation, that is calculated as the ratio between the energy absorbed from the process, so the heat that we avoid in our freezing tunnel to frozen the vegetables, divided by the electricity consumed. So is a common indicator that describe our efficiency for the freezing for the freezing of our vegetables. And of course, it's quite easy to understand that higher are the COPs, higher are the efficiency of our process. So what we have to measure with all these sensors that we have installed in our process are, of course, the amount of energy absorbed, the consumption of the refrigerant fluid, as well as temperature and pressure. Also here, I don't want to go deep in thermodynamic aspect of the process, but what we can summarize is just the functioning of our production processes that is characterized by one compression phase, where the ammonia is compressed, one condensation phase, one expansion phase, and one evaporation phase. So it's a classical thermodynamic cycle to absorb the heat within our freezing tunnel. So the tunnel in which the vegetable pass through is characterized by an heat absorption that represents the energy that we absorbed from our tunnel to frozen the vegetables. So the COP is measured, as we have said before, by the ratio between the heat absorbed in the tunnel divided by the electricity consumed by the machines. And of course, the electricity consumed is the electrical energy purchased by the company and consumed by the machinery. And the energy absorbed is proportional to the enthalpy that characterizes the evaporation phase of the process. At the same way, the process is characterized by high level of water consumption because we utilize water in the cleaning phase, in the washing phase, in the blanching phase, as well as in the freezing phase of the tunnel. And for this reason, we have installed a series of new meters to measure the water consumption in the different step of our production process. All these sensors have been installed to create the IoT network on which the data space can be built on, because it's the first level where we gather the data that comes from our processes, data that are collected, analyzed, and optimized by artificial intelligence algorithm. So just for giving you a brief example of the data that are gathered from these sensors, we have a series of food processing data that are related to the type of product that the process produce. So for example, the product that is produced in a certain part of the production process, the state of the machines, the time of the production, the quantity of the production, and all the information that characterized our production process, and that comes from the manufacturing execution system of the company. Another big data set, of course, is related to the energy consumption data. So all the information gathered from the meters installed for the energy measurement, so the amount of electrical energy consumed for a certain type of production, for a certain type of machines, in a certain type of state of working shift, or of equipment, and so on. And thirdly, some data related to the freezing installation monitoring. So the type of equipment, the type of pieces, and the type of characteristics that are related to the machines, the equipment, and of the tools that at the end are utilized to freezing the vegetables and to measure the COP of the system. All those data are collected, analyzed, and trained to apply different type of artificial intelligence algorithm. So we have identified different tasks of artificial intelligence that can be utilized to optimize those data. For example, this is the energy budget prediction. So the data are analyzed to forecast the energy consumption according to the production data and to the weather condition that characterize the different type of vegetables. Another example is to utilize all these data set to optimize the forecasting of the electric failure of the systems, as well as to the water pump predictive maintenance. And in this case, we are analyzing those data thanks to the survival analysis models as artificial intelligence algorithm. Another example is the anomaly detection of the equipment. So the capability to find pattern within this huge amount of data set to detect anomalies that can lead at the end to an efficiency in the usage of water and energies. And in fact, as I said, this is another example of application of artificial intelligence tasks. So in general, the approach to build the AI toolkit of the CLARUS platform has started to analyze the priorities and the criticalities of the production process to find the correct AI model useful to improve this environmental sustainability data, and then train the different data set to apply this mathematical model and see if some possible benefits can be achieved thanks to this algorithm. Of course, all this approach to gather this data rely on a specific technical infrastructures that characterize the data space of the CLARUS solution. So in this case, in the Ardo use case, we are gathering the data, exploiting the OPC-UA communication protocol, that is one of the possible communication protocols utilized in manufacturing systems. So if we would like to summarize the layer architecture that we are building in CLARUS, we have the first level, that is the field level, where we gather all the useful information that I have described before, so electrical, energy consumption, water consumption, production process consumption, and so on. All this data, thanks to the sensor and to the creation of the information, of the IoT system, gather this data thanks to the OPC-UA communication protocol, and together with the data that comes from the warehouse management system are collected in the SCADA layer. The SCADA layer, that is the supervisory control and data acquisition layer, orchestrate the different sources of data, and the end elaborate and pass all the information to the manufacturing operations management layer. That is the layer through which the company is able to manage the production processes. So all the data are collected, or the KPIs are monitored, all the characteristics of the scheduling and of the production control are managed, and so on. And of course, all those data are stored in the manufacturing operations management database that can be accessed through SQL coding. And finally, all these data are analyzed in the last layer of the architecture, that is the ERP layer, so the enterprise resource planning level, where business intelligence and API can be installed to exploit the possible benefits of all the data analyzed in the previous layer of the architecture. So these structures of this flexible layered architecture is at the base of the CLARUS data space. So the data services embedded in the CLARUS data space allow the data collection, the data sharing, the interoperability, and the application of artificial intelligence algorithms at the edge level. That at the end are the basic characteristics that characterize in general a data space, and that we need to build a structured data space and allow the trustful sharing of environmental sustainability data. So in this case, we have some layers related to the collection, harmonization, and storage of the data. Then we have the application of the machine learning operation strategy platform, that is the set of artificial intelligence algorithm trained on the data that comes from the production process. And then we have the CLARUS data space that provide all the technological building blocks that we have described before to assure the identity provider, the presence of the correct governance among the sharing of the data, and the right policy to exchange information among the data owners, the data providers, and the data consumers. So what we have tried to do in CLARUS is to follow the guidelines of the International Data Space Association to create a new data space that is totally customized on the management and analysis of environmental sustainability data analyzed thanks to the artificial intelligence algorithm. So also here just showing an overall picture of the tentative structure of the data space. The same structure that I have described until now for the hardware company is also present for the other industrial pilot, that is the Onkayoki company. Of course, the selection of the artificial intelligence algorithm, like the examples that I've shown you before, to apply to the data set of the industrial pilot under analysis are totally related to the characteristics and to the need of the company. So it's not possible to generalize the specific mathematical model to utilize, because, of course, any type of process can have different priorities, needs, issues, and criticalities. But in general, the selection of the AI task start from the definition of the specific problem and from the data that, of course, are available in the process to be analyzed. Very briefly, few minutes to conclude the webinar and to highlight the way through which we are going to analyze the benefits from data space and artificial intelligence on sustainability parameters. This part is conducted thanks to the Green Deal Index developed in the CLARUS platform. As I have introduced before, the GDI is the third tangible expected outcome of the project that represent the overall indicator based on the Green Deal Index, on the Green Deal program priorities, and utilize to assess the impact of artificial intelligence. So, according to this approach, in which way we are utilizing the GDI in CLARUS? Well, according to the selection of the main sustainability priorities of the companies, we have aggregate all the indicators useful to analyze environmental sustainability performances in a unique index that is the GDI, and we are going to test this unique index to evaluate the impact of the AI toolkit, so the AI application in the two pilots, of course, before and after the application of the CLARUS solution. So at the end, the GDI is the matrix that we can utilize to measure the concrete impact of artificial intelligence. This is the main structure of the creation of the GDI. Also here, I don't want to go deeper in the technical aspect of the matrix and of the algorithm that we have utilized to develop the GDI, but we can just say that the identification of the indicators embedded in the final Green Deal Index range from different level of priorities in terms of sustainability performances. So the identification of the indicators start from an environment level, then to an enterprise level, to a process level, to a process segment level, and to equipment level. This because, of course, the priorities of the companies in terms of indicators to optimize can be different and at different level. For example, the COP, the indicators that we have seen before, is an indicator that measure the energy efficiency of our system at process level. So at the end, all the indicators are selected and then aggregated according to a specific methodologies that we have developed in CLARUS, and that provide at the end this final Green Deal Index. For example, this is a set of indicators that we have selected for the ARDO use case in CLARUS, that range from the decrease of the equivalent CO2 emission to the decrease of global warming impact of the freezing installation, to the improve of the performance of freezing installation, as well as to the increase of the availability of freezing installation. So all these indicators comes from different levels of priorities of the companies and has been selected according to the priorities of the company itself. Of course, all the IT structures that I have summarized before that represent the technical structure of the data space allow to gather, collect, and analyze all the data to feed the information for the calculation of the key performance indicator that at the end produce the GDI. So for example, here I put just an example of one indicator for the ARDO use case. Okay, the level of priority is the enterprise level. The indicator is the energy efficiency. the measurement attributes, so the environmental sustainability data that we need to gather from the field level thanks to the sensors that we have installed are related, for example, to the total active energy, so active power pumping system, active power compressor, active power condenser, and the produced ton of the production. And of course, these measurement attributes are part of the equipment of the process under analysis, that in this case is part of the freezing installation, so the ammonia system, the compressor, and the condenser, that in turn are part of specific steps of the production process. Okay, so for each indicator that has been selected for the company, a Green Deal ontology, so a semantics of all the data, and at the same way the technical infrastructure to gather and analyze this data has been developed. In this way, the company can detect in a very easy way all the information and all the sustainability data that we must gather to calculate our Green Deal index and to utilize to train our artificial intelligence algorithm. Okay, just one very fast example of one indicator that I've shown you before. This is the decrease of the equivalent CO2 emission. And of course, the impact of artificial intelligence for decreasing equivalent CO2 emission is on different AI objectives that are, for example, the optimization of the electric failure, the optimization of the energy budget, and so on. And this is an example on how the GDI can be calculated. So at the end, according to the methodology that we have developed, the calculation of the overall Green Deal index rely on the weighted sum of the different indicators with their weight of importance and on the different level of hierarchy of the company together with the weight. So it's a totally weighted sum of the different level of this indicator to calculate the overall GDI. So the main scope of application of the GDI is to calculate these performances before the CLARUS solution and these performances after the CLARUS solution in order to quantify the benefits, the concrete benefits of the CLARUS solution according to the GDI parameters. In order to support the company to evaluate these results in a very easy way, we are utilizing a traffic light system to evaluate the improvement of the AI toolkit according to the increased or to the decreasing of the GDI calculation. I think that I have finished the time available to tell you some characteristics of the CLARUS solution. I would just to conclude this webinar highlighting that the majority, if not the total content that I have described in this webinar related to the CLARUS solution, so to the CLARUS project, are totally true for cosmetic sector. So under a process management point of view and under a twin transition point of view, the characteristics of the production processes of cosmetics industries and of food industries to improve environmental sustainability performances are totally similar. So the approach that we are conducting in CLARUS project can find a lot of useful space and innovative solution also in cosmetics supply chain. I stop myself here. I hope that I have described at least some useful insight related to the application of these technologies on Green Deal index, Green Deal parameters. So we have concluded the time, but of course, I'm available to any feedback, comments, or to answer to any question or curiosity related to the project.
Thank you very much, Roberto, for this super presentation. I hope it was valuable and interesting for all the attendants. I don't see any question in the Q&A chat, so it means you were crystal clear in your explanations. But of course, if if anyone has any question, we can still use some of these last minutes to have a look at it and try answering. So if someone wants to type a question, feel free to do that. We can wait 1 minute for any curiosity to be asked. So then, of course, again, the recording will be shared with you, and also the presentation will be shared with you, together also with the links to the Act for Cosmetic surveys, in case you want to support us in our mission of helping European cosmetics industry keep innovating and staying competitive. So we truly need and would appreciate your contribution also on that. Okay, I don't see any question in the chat. So again, thank you all for your attention, for attending. Thank you so much once more to Roberto for providing this very nice insights and his expertise. And wish you all a nice evening and a nice holiday in case you, I think you will be soon for, most of you will be on holiday soon for Easter, so happy holiday as well. Thank you. Bye-bye.
Thank you. Bye. Have a nice evening.